Good morning or good afternoon. Hi, my name is Yasmin. This video you are watching will thoroughly take you through the ongoing issue of air pollution and the effective solution of multi-biome biofiltration methods. This video will explore the causes, effects, and current solutions of poor indoor air quality, and lastly propose a solution effective in purifying air in indoor spaces and the removal of gaseous particles, whilst remaining an aesthetic appeal. Good morning. In order to develop a better understanding of this topic and why it is of any concern to us, let me explain to you a little of the issue's background. Within the past few decades, air pollution has been an area of concern within the Western population citizens, in which they are spending 75 to 90% indoors. With recent lockdowns, we can surely guess this will even go up. Indoor air pollution can come from things such as excessive moisture within buildings, VOCs, which are volatile organic compounds, which comprise of chemicals and bacterial growth. A study has linked the mold presence with occurrence of SBS, which is also referred to as sick building syndrome, bringing out cold-like symptoms from individuals. As stated, there are a variety of sources and types of pollutants. Therefore, it will be hard to create a solution that will be effective against several types of pollutants while being accessible and affordable. Take the exemplary example. To combat excessive moisture, the popular solution is placing in dehumidifiers to directly remove water vapor, reducing moisture and dampness indoors. However, this isn't an appropriate solution for VOCs and bacterial growth. Therefore, bringing us back to the much needed solution that we can tackle most of these issues and is profitable, accessible to the general population, affordable, and effective. It must also meet the objectives of all of our stakeholders. Now, a figure that may shock the viewers is the number of death by risk factors that was compiled in 2017 by the Global Burden of Disease. As seen where the arrow is pointing, 1.64 million people are at risk of death due to indoor air pollution. Common air pollution sources can also be seen in this pie graph illustrated. Now, the pollutants can come from many activities happening indoors, such as cooking in homes. This is mainly for homes that use gas or other form of combustion-related source. Now, smoking in enclosed building is also something else. Temperature controls, such as using aircon, this circulates the same air over and over again, which is unhealthy. Now, we do need natural air ventilation, which is much more recommended, such as opening up a window or a door so it can reduce the exposure to stale air and excess CO2. Of course, when talking, there are many more things to be mentioned, such as fragrances, the building material, and the excessive moisture. Some of the existing solutions to indoor places include ventilated cavity systems. Ventilated cavity systems are passive cooling systems that aim to control the problem of excess moisture in buildings. They work to protect structures from potential external sources of liquid and moisture, such as rain. The framework of the building is such that it is detached from the outer layer of the building material to prevent the potential issues of water leaking into the framework. Essentially, it is made up of two layers, the framework and the cladding on the outside, which are divided by a corridor of air in the center. Material on the outside will be a barrier from wind and rain, and the cavity in between ensures the penetration of water is reduced. Another worth mentioning is the drainage planes. Drainage planes are water-repellent materials located behind the cladding of a building and are designed to create a drain path for water that passes through buildings' claddings. One that is most commonly used, as seen in the image, is house wrap. Botanical biofiltration is another method that is added to the list. Botanical biofiltration involves the integration of greenery into biofilters in order to use the microorganisms that reside on these systems to remove pollutants from water or air. This method has proven to be effective in removing VOCs as well as inorganic gaseous compounds too. Active biofiltration involves the removal of contaminants from the continuous flow of air through biological processes. An example of active biofiltration are plant-assisted biotrickling filters. These are essentially biotrickling filters connected to hydroponic plants with a continuous feed of nutrients to their packing material and constant exposure to a stream of polluted air. Another thing is passive biofiltration is where the microorganisms in the system capture pollutants through precipitation, concentration gradient, pressure variation, and wind speed. There are a number of ways in which pollutants can be configured in a plant system. Now, we can have a quick skim read through the stakeholders, which you can see right here on the table. These are all the main stakeholders required to be on board to complete the solution that we are about to state. Stakeholders are defined as any person or entity that may be affected by the outcome of or may affect the outcome of the project. Now, their roles, impacts, and requirements must be considered when determining a beneficial and successful solution. As you can see at the bottom as well, the environment is stated as it can affect us through climate change and local pollution issues. It can be impacted by our actions, and we do have the moral obligation to nurture it. Thus, I think it is something worth mentioning. This brings us to our proposed solution. After thorough background research and planning of multiple solutions, the proposed solution's aim was to develop a biofilter which utilizes plants to reduce concentration of indoor pollutants. It is based on the ability of plants to reduce concentration of VOCs from indoors by up to 96%. The plants that will be included are indigenous to arid dry areas, in which have been shown to reduce humidity in the air and balance out the excessive moisture. The solution will address the objectives of accessibility, affordability, and effectiveness while also addressing each of the stakeholders' concerns. The solution is brought to draw influence from both active green wall modules and HVAC systems, as well as used as an aesthetic feature indoors. Materials consist mainly of hydrophonically grown plants as they are easy to transplant and easy to monitor. There is a water pump, a tank that is used as a batch mixture for nutrients and can have additional air pumped through, and the HVAC's blower to support the system. Now, construction has a couple of steps. There is the plant roots that absorb the contaminant, which they consider to be food. The biofilter is constructed in several layers, the first and the second, which was the plant and the soil layers. Behind the plants, there is an active biofilter. There are individual pipes that form the air diffusers. These meet up with the main manifold above and are used to provide air to the HVAC system by sucking air through the soil. Our main calculation here to consider is the 1 to 100 to the floor area or less. The environmental impacts to state are little to none, as the proposed system will have an overall positive impact on the environment. There are no regulations or policies being broken by Australia, as they do not have any specific measures in places to dictate air quality in indoor environments, with the exception of workplace circumstances, of course. With concern to the economical side, the major cost will be in maintenance, as it includes actual living plants that will need taking care of and will cost about $5 per square meter for maintenance, as well as a little money and energy poured into cooling. Other costs include the initial construction cost of labor, which will be around $60 per square meters, as well as $60 per square meter for the actual soil, the vertical pot, and the plants to be included. Lastly, you can see here the project schedule timeline is shown. It can, however, be broken up into 3 key sections, which is pre-installation, installation, and the actual post-installation, which each has a description. Now, to sum up everything, in the end, the aim of our project was to create a solution to improve the occupant standard of living regarding indoor air quality. The focus was to improve on the effects this has on human health and safety. So a variety of sources and pollutants were found to be present indoors, ranging from VOCs to mold, and although the air pollution in indoor spaces will remain an ongoing concern, with the solution of an active green wall incorporated with a HVAC system, the air quality of indoor spaces will immensely improve the health and safety of all of our occupants.